All right. Welcome back to, let me actually reduce the gain here. Welcome back to another episode of LeetCode Live, where we do daily LeetCode streams, trying to help engineers grow in their careers and get better at the one thing that blocks a lot of us from making that next step, and that is LeetCode. So just like I start every stream, just to go over some stuff. So here we have the YouTube channel, LeetCode Live, daily LeetCode streams. If you want to go ahead and you need a place to start, the best thing to do is visit this playlist right here, LeetCode Live Easy Collection. You can just start at this first one and go through every single one. Each video provides helpful chapters and links to the LeetCode questions themselves. On top of this, since we've been doing a lot of different questions, I've gone ahead and I've been compiling my own list of questions which I deem top quality over here in raphaelslist.com. There'll be a link in the description as well. You can just expand this details menu. You can see all the questions that we've worked on, at least the ones that I think are high quality, and you can even filter by topic if you so desire. Sweet. So without further ado, let's go ahead and get started. We're going to see how many we can do today. I know yesterday we were sort of a little bit backtracked. We sort of got sidetracked rather, since we had my computer just decided to not operate very well. And I actually went ahead and ended up doing a computer reset. So that's why you might see some things looking a little different. And I just realized I don't even have the extension for here. So let me do that now while I have a second. Okay, dark side. Let's do this. And we should also go to extensions, right? Okay, cool. Are these already all on? Well, I guess we'll find out. So we left off yesterday at 153 questions. We only did one yesterday because of the issue that we had, right? Let's go ahead and just start on the next one here. Let me make this 100 per page, just like we were doing last time. And let's see, this one, it was kind of like strange. So let's just go to find common characters. And let us see, so let's do JavaScript. And now one thing I'm already realizing is prior, you know what? I think I need to enable this guy right here. Yeah, there you go. Let's refresh this again. Oh, we got our unofficial mascot back. Can we, let's see, options, invert image color, hide logo, show mascot, enable dark theme. Was this always, oh, no, wait a second. There's another way to do this here. Theme, there we go. Is there a way, like Monokai? I think I did Monokai before. Okay, let's also make this the highest. Well, I'm gonna do tab size 2 spaces. Vim, okay, this is looking a little bit better. Nice. Okay, awesome. I hope everyone can see that. Yeah, let's just go ahead and get started. So here we have, given a string array words, return an array of all characters that show up in all strings within the words, including duplicates. You may return the answer in any order. I think we even zoomed in a little bit here. Nice. I think this is gonna make it a lot easier for people to watch. Let me also double check to make sure the output is good. Okay, nice. Sounds good to me. Okay, sweet. All right, so here we have Bella, label, and roller. Did not mean to do that. And we have ELL, so just the ones that show up in all of them. So I think what we can do is almost like an intersection. We only ever want to see, like, let's imagine we start off with like an empty array or like an empty object, and then we have an object that we're working with now, right? So I can say, let's say like for Bella, if B is not in the previous one, which is not, I can include it. E is not in the previous one, so I can include it. L is not in the previous one, and A is not in the previous one, so that's fine. And then when we get to label, this one becomes the previous one, and now we can sort of look at label. I'll say L is not, well, I should only say if it is, right? So like L is inside the previous one, maybe I should consider that one, right? I definitely want to keep that one. Let's see. Oh, but they're also including duplicates here. So how could we do that? Given an array string, array words, return an array of all characters that show up in all strings. Let's see. Maybe I don't really need to even consider a previous one, right? Maybe I just say the first one is Bella. What happens if I have a counter here, where I have B, I have E, I have two L's, and I have one A. Then for this one, I say, okay, I have one L. So if we have one L, do I also increase it here, or do I just remove it? Maybe we just keep it. And then I have an A. Okay, then I have a B. Yep. Do I want to increment the frequency for each one of these? Bella label, anything that's found in here, I keep, and then anything that's found in here, or any letter that's also in the one that I've currently already made. If we're at label, how is it that we can, let's see, I feel like I sort of have like an idea of what I want to do. It's just a matter of like putting that into code. So we have label, L, that is included, so we should keep it. Anytime we see a letter that's included, we keep it. I see an A, and there was an A before. So does that just mean I keep it, or do I like increment it? Because even if it's duplicates, LABEL, find common characters that show up in all strings, including duplicates. It doesn't also, like, I think the first time I ever tried to solve this question, I wanted to do something where I said, oh, if like the character count at the end is equal to 3, because I thought each word would be distinct or something, or have unique characters, but that's not the case, right? Because we can have duplicates. So 2, 2, and 2. So 1 always shows up in each. Now if I instead had an array where I kept track of all the different characters, how many times does it show up in each one? I don't think I want like a map. There's gotta be like I think there's an easier way of doing this. So Bella, label, roller, cool, lock, and cook. Interesting. Cool, lock, and cook. How do I take advantage of like, oh, or maybe anytime I see like, okay, there's like a BE, double L, and A. If I see an L, do I just decrease? Well, okay, if I increase the L and then I see an A, I increase the A. I see a B, I increase the B. I see an E, I increase the B. I see an L, I increase the L. And then when we get to roller, we can do something similar, where we have RO, double L, ER. But then still, how does that get us? How do we still manage to keep track of the duplicates? How do we keep track of the duplicates? Return the answer in any order. I'll give myself like, normally if I'm stuck like this where I'm just having a hard time thinking about it, I might just decide to skip it and move to the next one. You may return the answer in any order. Because what is it that we want? I need to know that 2 L's came from 1, 2 L's came from 2, 2 L's came from 3, and because there's 2 in each one, then we return 2 here. What if we also, I don't know, I was gonna maybe consider like sorting it, but I don't think that's good. If L is in there, leave it, okay. A is in there, we leave it. B is in there, we leave it. E is in there, we leave it. L, there's another L, so we leave it, okay. Then we get to R. R is not in there, so we don't. I'm just gonna go to the next one. I'm having a difficult time with this one, and it's tough for me to like. It's hard for me to like put it into code. All right, relative sort array. Given two arrays R1 and R2, the elements of R2 are distinct, and all elements in R2 are also in R1. Sort the elements of R1 such that the relative ordering of items in R1 are placed in the same as in R2. Elements that do not appear in R2 should be placed at the end of R1. Okay. Given two arrays, elements of R2 are distinct, and all elements in R2 are also in R1. Okay. 28, 6, 22, 8, 44, 17. Same as in R2. The relative ordering of elements is the same as in R2. 2, 3, 1. So 2 to 3. What? Sort the elements of R1. Oh, no, wait. 2 to 1. Elements that don't appear in R2 should be placed. This is confusing for me to understand. Oh, we put... No, see, that also doesn't make sense. We put all the 2s first. Then we put the 1s. We put the 4s. All the 3s. All the 9s. And all the 6s. And then whatever ones... Okay, I see. How many numbers are we going to have? We're going to have 1,000. Oh, okay, so it's just telling us for every single... Okay, we should get... What if we had a frequency of all these different characters? What if we had... Let's see, 2... Let me just copy this here. Okay. If we had 2, that's 1, 2, 3. Okay. How many 3s do we have? 1, 2, 2 3s. How many 1s do we have? It just looks like 1. How many 4s? We only have 1 4. We have 1 6, 1 9, or 1 7, 1 9, and 1 19. And I think for 6, I probably meant to put what? 1? I don't know why I put 7 here. So now it's saying put all the 2s first. So we put 3 of these. Then we put put 1. There's just 1. Get to 4, 3, 9, 6. And then at some point, we're going to be left with only some of these. So the ones that are not, elements that do not appear in R2 should be placed at the end of R1 in ascending order. I almost feel like the right way to do this, and if they're not in those. So this will take care of all the ones that are. Now if I just have some... Yeah, I think we can... What if we had an array? Okay, there's one way that I can do this. I can create an array of nums. Let's just say frequency. We're going to make this equal to an array of size 1001. That way we can have like every single number. Now going through this, I want to store the frequency of all of these numbers, or rather all the numbers, right? For const val of R1. Inside of frequency in val, I want to do plus or equals 1. That way I have a frequency of all these numbers. Now what I can do is I'm going to create 2 different arrays here. What I want to do is I want to say const result, going to be an empty array. And now we're going to go through for const val of R2. Right, now we're going to go through R2 and we're going to get so we're going to go to like index 2 inside of frequency, and that's going to have however many 2's there are, and we'll just output all those 2's. We'll keep doing that all the way, and then we'll also decrement the frequency at that index, and then at the end we'll go through frequency again, and for anything that has something left, that means that we didn't find it in our initial scan, and we'll add it. Maybe not the most effective way of doing it. Nice. Awesome. Hey, glad to have you, MMD. Have fun. I need to go to bed. Okay. By the way, can you tell me if everything sounds good, just to make sure like my voice sounds all right, since this is like a new machine essentially. I had to reset everything, so just wanted to make sure everything sounds good for the people watching. Okay, so let's go through here, and now we can say while frequency of val is greater than 0, we're going to push. Nice, all good. Thank you, man. Appreciate it. We'll push val, and then we'll also decrease the frequency. Minus equals 1, right? So that'll just give us however many we have at that location. Then what we really should be able to do is we can now go for let I equals 0, I less than frequency dot length, I plus plus, if frequency of I is greater than 0, let's see, or I can just say while frequency of I is greater than 0, we're essentially just going to do the same thing. Result.push frequency of I, and then we'll say frequency of I minus 1, and then we'll do return result. Let me see what this gives us. Kind of like, not like my favorite solution. 222143396. Oh, I think this should be, yeah, this should be I, right? This should be I. Let's try that. 7 and 19. Let's try both of our test cases out. So this looks good for both. Very curious about what percentage we're going to get here. 37.08. Yeah, it might not be the most efficient solution, but this one's pretty tricky. 82.07. That's not too bad. And we'll analyze it ourselves also, so that way we can figure out. We'll see. Okay, 78. That's okay. So let's think about this, right? We have this initial thing right here, which is going to be constant time because it does not matter the size of R1 and R2. This will always be size 1001. All right, so let's say that this is going to be constant space. This right here is going to be O of R1 dot length, right? And then this will be, this one's going to be interesting because it's really like O of R2 dot length. And for some of these, see, I never know how to describe this piece because this, it's just dependent on however many numbers have a frequency greater than 0. So O of whatever that is, maybe it could just be some arbitrary like N or something. Or maybe in this case, we can make this Z, and I'll get to that in a second why I believe that is. This, again, is just going through frequency, right, which is constant, but this is also going to incur some other like Z variable, right, some unknown time that we're not aware of. That's how I sort of like think about that. So if we think about this, let's say this is X and this is Y, right? That's C, and here it's going to be O of 1 because we're going through frequency. So if we kind of like put all these together, what is it? It's 1 plus X plus YZ plus Z, whatever that comes out to. Right? Like this is what I think the time complexity would be. There's probably like a way to like factor this out. Honestly, I haven't done this sort of math in a while. YZ plus Z. Can we do like Z1 plus Y? Something like that. Plus Z1 plus Y, which I guess we would like just do anyways. Plus Z plus ZY. Like I feel like, and maybe this is like too specific, but I feel like this would be the time complexity. And the space complexity for this would just be constant. Or rather, no, it wouldn't be constant. It would be O of N. It would be linear, but it's mostly dependent on, It's going to be at least as big as R1, right? Oh, didn't want to see that. I believe it's going to be at least as big as R1. So we can just say a space complexity of n. So let's submit this one more time. Let's see what the LeetCode gods are granting us. Okay, 97.87. I'm cool with that. Let's see what discussions have to say. I'm very curious about this one. Python easy. Okay, no sort. A few loops. Let's see this one. Okay, for j and I1, if I equals j, A3. Okay, this is a little bit difficult to understand. Let's see most votes. There you go. That's what I was looking for. Using counting sort. Because 0, we can use an array to count every element. Go through every element in the second array and update values of the first array based on the order in the second array. So count, n equals count, and then again. Oh yeah, pretty much the same thing. Now this is time O of 1. N through array, but isn't this going through... Wouldn't this... I understand that looping is 1000 is constant, but you're still looping through, and that means O of n plus n time. Correct me if I'm wrong. Yeah, I agree with this. Because both m and n will not exceed length 1000, then that's what our time constraint is. Interesting. Anyway, this is the solution that we came up with, so that's good. I feel like I wouldn't have been able to do this a little bit earlier. And when I say earlier, like a couple months ago, oh, hey, what's up, Rashawn? Good to see you again. Awesome. Glad that we're back up and running today. Yesterday was a fun stream. All right, sort array by increasing frequency. All right, so given an array of integers nums, sort the array in increasing order based on the frequency of the values. If multiple values have the same frequency, sort them in decreasing order. Okay, so let's think about this. I think that we can just, again, create, let's see. If we create, let's take this array. We're going to do the same thing we did before, right? Because look at our bounds here. This is 100, which means probably we can do something very similar to the question prior to this one. We can keep an array and use that statically sized array to hold the frequency of each one of these numbers. So we have nums 1. So now let's imagine in our array, right? Like this is index 0, 1, 2, 3. Right, so we have 1, 1. I'm just going here from left to right. So we have 1, 1. We have another one here, so that's 2. We have 2 2s, and we have 1 3. So let's see. With the same frequency, this is 0, 1, 2. 3 has a frequency of 1. 1 has a frequency of 2, and 2 has a frequency of 3. 0, 1, and 2 have the same. If multiple values have the same frequency, sort them in decreasing order. But wouldn't this be 3 has a frequency of 1. 1 has a frequency of 2. Oh, yeah, there's 3 3s here. Okay. So 2 and 3 both have a frequency of 2. So they are sorted in decreasing order. Now, do they need to be right next to each other is my question. Let me take this one first, and I'll show you kind of like what I mean by that, because that might make things a little bit more tricky. But let's say, oh, and this is also negative numbers. Ooh, that's going to be nice. That's going to be tough, but we're going to figure it out. Let's imagine this index is negative 1, 0, 1, 2, 3, 4, 5, 6. I see, wait, what's our maximum positive is 5. I think we'll need a couple of numbers here. Let's say this down here is negative 6. We have 1 negative 6. So I'm going to remove that. We have a negative 1. So negative 6, 5, 4, 3, 2, negative 1. Then we have 1, 1, 2, 3, 4. We have 1, 4. We have a 5. Okay. 2, 3, 4, 5, 6. We have another negative 6. Another 1, another 4, and another 1. So over here. So they want me to sort it relative. So we would put everything with 1 first. So that should be what, -1 and 1? Oh, did I miss the 5 in there? Yeah, okay, the 5. I should have a 5 in there. Oh no, 5 is 1, okay. And you have -1. And what happened to the 1? We have 2 1s. So you go through all these, and then what? Do we go through all the 2s? So it should be in decreasing order. So yeah, it should be 4, 4, -6. This output's very strange. Unless I just like butchered it. Given an array of integers, nums, sort the array in increasing order based on the frequency of the values. 3 has a frequency of 1. Okay, yeah, I keep getting this mixed up here. We're gonna create a new array again, but this time I'm just gonna use an object literal. -1, we have 1. We have 1 1. We have 1 -6. We have 1 4. We have 1 5. We have another -6. We have another 1, another 4, and another 1. Okay, let me line all these up here. Okay, so this should be in order of, okay, so it should be the 5 first, right? These all have the same, and they want it in -1 4. That's the part that I don't get. Why would it be? It should be 5. 5 has 1, but -1 has. Yeah, where did I get that -1 had 1? Okay. 4 has 2. 6. -6, -6. 1 1. They all have the same frequency. Sort them in decreasing order. 4 has a frequency of 2. -6 has a frequency of 2. Oh, okay. 4 -6. I think it will just work out that way. But how many? Yeah, I think we can create an array. I think we can create an array that keeps track of frequencies, and we can start from the back and iterate downwards. And we can sort of do what we did before, where we're doing a while loop and pushing the new value onto it. Now, how do we know that we're done? I guess we know that we're done when we've already accounted for all the numbers in the array. Or could I just sort based on frequency in the map? What if I just try to use like a native sort? What if we do const frequency for const val of nums? Here we can say frequency of val equals frequency of val plus 1 or 1. Could I just do nums.sort AB, where frequency of A minus frequency of B? Like, will that work? 3 1 1 2 2. I mean, is that crazy to do? Let's see. It works for one of them. Let's check the other ones. 1 2 3 3 2. I mean, yeah, that. No, wait. Almost. It doesn't know how to account for ones that are similar. So it almost works. It almost works if we use like the native sort, but we need to come up with a more clever way of doing that one. And I think we can just do what we did. I could come up with one way of doing it, but it doesn't. And we also have negative numbers too, so that just makes it like way hard. So how should I account for negative numbers? If I had an array of size 200, or if I just had an array of, and I just go from the back all the way down, but that's not going to help because the sorted array would be nice. What I want to do is I want to create an array and have negative, like I want to be able to store negative numbers in there. How do I know if I'm looking at, yeah, that's going to be weird to try and do all that like mapping. 2 and 3 both have a frequency of 2, so they're sorted in increasing order by increasing frequency. Frequency of 1. 2 has a frequency of 3. How do I consider negative numbers? So like if I have an array of size 200, I can always say if it's a negative, like if it's a -1, does that mean that I should put it in position like 99? Like my 100 will be 0, but then everything you got to map. Yeah, that mapping just seems really odd. 3 has a frequency of 1, 1 has a frequency of 2. It's a tough question. Let me see what we have in store for us after this. The reason I'm kind of skipping over a couple more this time is because actually I have family over right now, but I gotta stick with my streaming. So it's actually like it's just a little bit harder for me to concentrate because after this I'm planning on doing like this barbecue. So I'm like thinking about the barbecue in the back of my head, to be honest. But I'm excited for this too because I know I want us to be able to at least solve a couple of ones. So maybe I'll just get to some that I've seen before. That way I can still provide some value for all you guys. But we can still get to some. Like this one I think is really good. And I think it's gonna make a lot of sense once we look at it, right? So convert a sorted array to a binary search tree. So one of the properties of a binary search tree is that every child on its left is less than the parent, every child on the right is greater than the parent. So like if I want to change this sorted array, I can't just, if I want to modify this sorted array and make it into a binary tree, I can't just pick any arbitrary value as the parent, right? Like if I say pick 10, like there's nothing less. I mean, I could make a tree that way, but then it'll be heavily skewed to the right, right? Because -3, 0, 5, and 9 will all be right children. And it might be helpful if I don't even know if I have, yeah, I don't have Excalibur saved anymore. So let's say we have 10, -3, 0, 5, 9. So let's come here, right? If we have this and I pick 10, like arbitrarily I say, oh, I'm just going to pick 10. What will happen, right? If I start drawing this tree out, like, okay, let's say -10 is the first one. There's nothing less than -10, so -3 is larger. So I just make this one -3, and then 0 is larger, so I just make, right? So if you think about it, they want it to be height balanced, but this is like really heavily skewed in one way. It's not even really a binary tree. It acts more like a linked list. So what we should do is we could take the midpoint of this array, and that could become the root of this tree. And then we sort of recursively apply this formula to come up with all the other ones. So in the first one, we say, okay, the root of my current tree is going to be the midpoint, which in this case it's 0, right? And then we say the root of this root's left child is going to be the midpoint of 10 up until 0, right? Because we only want to consider everything on the left, and then similarly everything on the right. And that's really all it is. I hope I'm like explaining that sort of clearly, but in every recursive function, we're always going to be getting the midpoint, and then we're going to be calling this function recursively with the left half. When I say left half, I mean the half to the left of our current midpoint, and then the right half, the half to the right of our current midpoint. So you can actually like make this like really nice. So if you ever get to a nums, let's think about our base case, right? If we get a empty nums, so let's say like not nums or nums.length is equal to 0, we can just return null, right? Or we can say const root is equal to new tree node. And what's our val going to be? Well, we need to get the midpoint, right? So say const midpoint equals math.floor of nums.length divided by 2, right? So nums.length here will be what? 0, 1, 2, 3, 4, 5. 5 divided by 2 is 2. We're going to truncate it with floor. That'll give us midpoint at 2. So we want to create a tree node where the value is going to be 0. And we can get that by using the current num, right? And passing in midpoint. Awesome. Then we can say root.left is going to be equal to actually here we can say root.left is sorted array, because this function will handle creating a new node at that root. So in root left, we just want to pass sorted array. And what is it that we want to pass? We want to pass that left half, right? So your language of choice should probably have like a slice method. JavaScript does. In the case of the left method, we want to go essentially from the beginning of the array until midpoint, because the slice method includes everything up until the midpoint, but not the midpoint. So here we can say, I want to go from nums.slice of 0 to midpoint. Right? And then we can say root.right equals sorted array to BST. Now we want to go from the 5 all the way to the end. So we can say nums.slice midpoint plus 1. And if I don't provide a second argument here, it just goes all the way to the end. And then at the end, we just return root. So let's think about this here. All right, 0, -3, 9, -10, 5. I remember solving this question for the first time more than a year ago, and I felt very good because it's a great question. It's pretty challenging, I think, 91.90, so that's pretty nice. Let me do something before I forget. This common characters, is that the one that we did? No, we did relative sort array. I definitely want to add this to the list of questions that I like because it is challenging and it's a good one. This one here, let's think about the time and space complexity. So we're going to have to create for every value in nums, we're going to have to create a new node, right? So that's going to be linear time because we have to traverse the entirety of our nums array. As far as space complexity goes, I think it's, honestly, I'm not sure if nums.slice takes any extra space. Is it creating, maybe it's creating a new array and giving that back to us? But this, like the addition of this plus this is essentially the size of nums. So perhaps the space complexity is just linear because we'll just add up 1/2 plus another half and that'll give us the whole, or where we currently are with nums. So I'm fine with saying that it's a linear time complexity and linear space complexity. So the reason that, again, we pick the midpoint here is because we could technically construct a tree with any of these values, but if you don't pick the midpoint, you're going to have a tree that's heavily skewed either left or heavily skewed right. And they say here we want a height balance tree. So that's really the most important part. And the nice thing is the image kind of gives you a hint. Like here they're picking the midpoint. Here they're giving the midpoint. 1 and 3, if you look at this, well, they're saying either work, but if you do, right, 0, 1, the length is 2. 2 divided by 2 is 1. So here, one of the parents is 3, so they're saying that that's okay. So I don't think it's creating any space. Yeah, honestly, it might not be. So it could also be constant. And let's look it up actually. MDN or array slice space complexity JavaScript. Let's see. Slice. Is this space? Runtime complexity. No, this is runtime, not space. Time complexity of splice and concat. I want slice though. Big O JavaScript arrays. It makes sense for the time to be O of n, but yeah, not really sure about the space. It could be constant or it could also be linear. That's what I would label it as. Okay. Toeplitz Matrix. That one sounds crazy. Ooh, okay. Given an n by n matrix, return true if the matrix is Toeplitz. Let me also, I keep forgetting this, but let me make sure I add this to the list of questions that I like. Yeah, because I want to add this to the site later. A matrix is Toeplitz if every diagonal from top left to bottom right has the same. Oh, I see. Okay, this could be done in a loop for sure, right? And I think the very important thing to do here is you absolutely need to draw it out. There's just no way. There's no way for you to do it without doing it. So let me see if we can do. Let me see if we can actually just create that ourselves. 1, 2, 3, 4. Is that going to be really annoying to do? You can't create like a grid in here. That would be really nice. Layers, fill. Yeah, I don't think so. That'd be really nice if you can create a grid. Well, hopefully you can just follow my mouse, right? Let's think about what we're doing here. We're gonna start. I'm gonna draw the cells we're going to loop through in hopes that we can find a pattern that we can formulate our for loop on. That's what I would do at least. So 9 is where? It's on row 2, right? Row 2, column 0. Row 2, column 0. That's like the first piece. And then to get the 5s, it's going to be row 1, column 0, and then row 2, column 1. To get the 1s, it's going to be row 0, column 0. It's going to be row 1, column 1, and then row 2, column 2. All right, so we have the 9s, we have the 5s, we have the 1s. Now let's do the 2s. We're gonna do row 0, column 1, row 1, column 2, row 2, column 3. And then to get the 3s, we're gonna do what? Row 1, which is 0, column 2, row 1, column 3, and then for 4, we're gonna have row 0, column 2. All right, so hopefully based on this, we're gonna have to figure out a way to come up with a loop of some sort. So let's see. Where do we see a pattern here? This is gonna be tough. But there might be a way. Let me see. 0, 1, 0. Starting at 2, 1, 2, 0, 1, 2, 0, 1, 2, 0, 1, 0. 0, 0, 1, 0, 1, 2. Oh, is this? Okay, so these are, oh no, it's not. 3, 2, 3, 2, 2, 1, 2. Does frequency help at all here? The grid diagonals in each diagonal. 1, 2 has different elements, okay. 2, 1, 2, so we're going here, 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 here. Maybe all I need to do is, maybe I don't need to exactly, I just need to know where I'm starting. Here, 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 here. I'm kind of doing something like this, right? I'm going from the bottom row to the top column all the way to the right. And every time, I mean, going bottom right is easy. So maybe I only need to focus about going from this row all the way to the top, and then from this column all the way to the right. Sort of like a two-way thing. Because again, going bottom right is always easy. Because we're just increasing both each time. So maybe I can have a function for that. Like given, I can say check, like const check diagonal. Here I'll take a row and a column. Let's see. Oh, so let's get the first num. Let's say const num equals matrix of row column. I'm going to focus on the diagonal part first, just starting from a row column and going down and left. So here we can say, right, so we want to essentially go while either the row or the column. Yeah, so I think we can do while row is less than matrix dot length and column is less than. Oh, and this, no, yeah. While row is less than matrix dot length and column is less than matrix of 0 dot length. I guess here we can take the row. Here we can say if matrix of row column not equal to num, we can just return false. Else at the end we just return true. And then here we do row plus or equals 1 and column plus or equals 1. So what do we do? All I did now was I just created a function that, given a row and a column, will traverse in a diagonal fashion, right? So we start at, let's say we go here, like num is row column of, we take row 2 column 0. This is less than matrix length and column is less, all right. So if matrix not equal to num, which it is going to be, we don't do anything. Row plus 1 is going to take us out here. So we're already out. Now we start here, row plus 1, column plus 1. So I think that's going to be good. So now really what I want to do is I want to check. Yeah, let's check left side. Let's see. So now let's do the rows. So I'll say for let row equals matrix dot length minus 1, row greater than or equal to 0, row minus minus. Here we can say if check diagonal of row and the column is 0, if at any point this is not true, then we can just immediately return false here, right? And now we can just take care of our columns. Once we get to the top here, and maybe here I'll just say greater than 0. That way when I get to 0, I can focus on the columns. Now here I can say for let column equals 0, column less than matrix of 0 dot length, column plus plus. I can take the same thing here. And now this will be 0. This will be column. Or at the end, we just return true. So let's see what this gives us here. True and true. Let's run all the different test cases. True and false. Let's run this. Okay, yeah, this one was man, honestly, I'm very happy with myself right now. I feel really good. This is a question I couldn't do before. I've never seen it, but like I feel like if I did see this one before, I wouldn't have thought about like what I just thought about. So I hope that you guys understand the solution I did here. Let me go through it one more time. So in the beginning, I was making this harder for myself. I was trying to write. I was thinking to myself, I know how we're going to traverse through this matrix, right? I'm going to start at the 9, go down. I'm going to go this way from 5, go down. Start from the 1, go down. 2, go down. 3, go down. 4, right? So I started writing all the different coordinates that we'd hit, thinking that I can find a pattern. But then I kind of realized, like, it doesn't really matter the pattern, because what I want to end up doing is I want to start, like, on this row, and just for every one of these, like, I start at the 9, do my thing. Start at the 5, do my thing. Start at the 1, do my thing. And the do my thing part is what this check diagonal function does. You give it a row and a column, and starting at that row and the column, it'll check to see if from here downwards this way, they're all the same. So all I have to do is I go from the bottom row all the way up until I get to this last one here, because I just want to consider this my first column, not necessarily the 0th row. And I run this function for each one. And then I start from the column all the way to the end, run the same function. So you said you had a little bit of trouble with this, Rashawn. Does my explanation help at all? I'm hoping it does. If not, please let me know, because I actually had some great feedback from, I think, Segoy. He wanted me, or they wanted me to just come up with maybe, take some more time and come up with a better solution. Maybe not a better solution, but like a better explanation. So does my explanation sort of help here? Heck yeah. Oh, awesome. That's really great to hear. And let's run this one more time just to see. I still feel like, are we going to be checking? Yeah, we're going to be checking every single element, right, in our array. So this will be m by n. And I'm getting decent percentages here. So can we see the solution? Group by category. Only if and if this leads to, okay, compare with top left neighbor. Okay, m times n, yep. Now this one, oh, we always compare it to the top left neighbor. Interesting, okay. Space complexity m by n. We have some other groups here. Yeah, actually this one's even cooler, right? We always compare every number with its top left neighbor. And if at any point that's false, then we just return false for the entire thing. So I think that's also pretty cool too. I think both of these solutions are fine. Nice. Let's see if we can do another one. So we've done 3, I think, right? Yeah, I like this question. I will add this one. Shift 2D grid. Given a 2D grid of size m by n and an integer k, you need to shift the grid k times. Okay, so 1, 2, 3. In one shift operation, the element at grid I moves to grid I j plus 1. Element at grid I, what's n? What's n minus 1? Oh, m by n, okay. Return the 2D grid after applying the shift operation k times. Oh, do they? Are we gonna have to do? I see. Okay, so what's ij though? Element at grid I, m minus 1 and m minus 1, n minus 1. Okay. I almost feel like I definitely want to start this off with k greater than 0. Now, very interesting thing here. So let's do for let row equals 0, row less than grid dot length, row plus or equals 1. We'll do row plus plus. For let column equals 0, column less than grid of row dot length, column plus plus. Now, there's a couple different rules here, right? I think I need to consider both of these first. So grid of I n minus 1 and grid of m minus 1 n minus 1. So what does this mean? M by n, right? So in this case, m is going to be the size, yeah, m minus 1 is going to be our grid length minus 1. So anytime I get to a row, element at grid of m minus 1 and n, okay, so there's a couple different, so if row is equal to grid dot length minus 1 and column is equal to grid row dot length minus 1, that's like one thing, right? What I'm doing is I'm just distilling these into their, right? Because m minus 1 means that only the elements that are of m minus 1 and m minus 1, we want to do one thing. Else if, so now it can be any element, but still the n, m by n, this is now the column, else if column, so let's just do this, we'll do one thing, else we just do the last thing. I think that's what it is. I think that's what they want us to do here. So let's say here we can say, This is for this first one. We'll say grid of row column. Or we should say grid of 0, 0 equals grid of row column. If column, grid, row, so this one we can say grid of row plus I of row plus 1 at 0 equals grid of row column. Else grid of row column plus 1 equals grid at row column. And now do we do this k times? Like that's seems crazy. But k minus equal 1 and return grid. I'm gonna go for it and see what happens. But this seems interesting. Kind of a weird question, but let's see. Ooh. Okay, I obviously did something very wrong here. I think, you know what? Probably what's happening is I'm overriding. Let's see, if row 0, row less than grid dot length, row plus plus, column less than grid row dot length. Because here the m represents the row and the n minus so element at m minus 1. So if row equals grid dot length minus 1 and column equals grid dot row dot length minus 1, moves to grid 0. Okay. If the column equals grid row dot length minus 1, grid row dot length minus 1, okay, we move that to grid of row plus 1, 0, or grid of row column plus 1. Grid ij. Grid of I, m minus 1 moves to, oh wait. Grid of row column minus 1. Wait a second. Yeah. No, I got this all messed up. This should be grid. This should be 0, 0, right? No. That was right. Grid of 0, 0 is going to equal grid of row minus 1 and column minus 1. But do they want me to do that? Maybe this should just be row. This should just be row. Grid at grid row column minus 1, but that's already if column is equal to this. Moves to grid of row plus 1 and 0, and that's still going to give me, do they want me to like create a new array? Is that in one shift operation, return the grid? So let's see, grid of ij moves to grid of, okay, then we get here. That's one operation. Example 1, input grid, oh, k equals 1, okay? So I moved this there, but then I get here. Once I've already moved it, I shouldn't consider it again, right? Need to shift the grid k times. I think I'm like overwriting values when I shouldn't be. Or should we perhaps be starting at the end? What if we started, I don't know if that will change anything, but we can certainly try. Grid dot length minus 1, row greater than or equal to 0, row minus minus. For column equals to grid minus 1, column greater than or equal to 0, column minus minus. If we do this, oh man, so close. So close. Okay, wait, this is good. I think k minus equals 1. Okay, so if in one shift operation, the element that's at grid of row column moves to grid row column plus 1. Grid row column to grid row column plus 1. Okay. The element at grid I, n minus 1, where n is the size, right? N is the size. So only if the column is equal to the grid row dot length minus 1, if column equals grid row dot length minus 1, then we should say that grid of row plus 1 at column 0 equals grid of row to column, because column is already n minus 1, right? Because that's the check we're doing here. If column is that, then column just stays as this. Else in this first one, it's the same thing, right? Grid 0, 0, grid row, column. Oh man, I feel like we're really close. I'm just curious to see, like, if I do all the test cases, because it could just be that we're close to the first one, but 4, 6, 11, 10, 9, 7, 13, 8, 12, 0. Okay, this one's a little bit weird. 6, 7, 8. Oh, that one's even weirder. Interesting. Well, we are a little bit over the hour. I know this stream maybe wasn't like the best one. I'm okay with that though, because we're just like, consistency is what counts here. So we did 3 questions today. The good thing is they were all like high quality questions. So what I'll do is after, probably like later tonight, I'll come back. I'll go ahead and update the website. I'll update the description for the video. I'll make sure everything's up to date so that people watching this can be sure that they're watching the latest stream, make sure they're doing the best questions. And yeah, thanks so much for everyone that was able to join. We had MMD, we had Rashawn, some people I've seen before, so thanks a lot. I really hope that this stream helped. And I'll go ahead and I'll set up the next stream for tomorrow so that tomorrow we can also do one of our streams. It probably will be earlier because I have to pick up my girlfriend at the airport at 6 p.m. So I might do it like at 4 p.m. Eastern. So we'll see how it is. But I'll let you guys know. Just be on the lookout for the stream when I put it out. I'll pick a time and we'll go from there. So thanks again, everyone. Hope you guys have a great rest of your Thursday and happy coding. Take it easy, guys. Oh, the website. Yeah, that's a great question. Let me log in to chat. That way I can actually put that here. So I have raphaelslist.com. That's my name. My name is Raphael. So I created raphaelslist.com, which is this website right here. So it takes all the questions that I think are the best questions that we've done so far, and it allows for you to look on here. And for every single question, you can click on like stream clip, and it'll take you to that section in the stream that we covered it. So that's just a way for you to like see my thoughts on it. It'll also link you to the LeetCode question, and it'll also give you this topics drop down, which is a little bit of a spoiler, but if you really need a hint, for example, you can click on this and you'll be able to see some of the different topics that the question covers. Or you can also just sort, for example, like by the topic up here. And yeah, you can just visit this website. I left a link there for you. And then you can even, I also open sourced it just for fun. So if you actually want to go and just like contribute or just look at the code or just have fun with it, you can also just look at the repo I created on GitHub. So yeah, hope to see you around there. So again, you guys all have a great rest of your Thursday. Happy coding. And